Hello, Algebra 2. How's every little thing? How about we talk about the quadratic formula? The quadratic formula is a pretty cool deal, actually. It is so much more than you probably learned in Algebra 1, and we're going to take a look at how it's derived and some of the other things we can learn from the quadratic formula besides just a quick and dirty way to, well, it's not really quick necessarily, but a dirty way, because it introduces a lot of opportunity for error, to a dirty way to solve quadratic equations. So here's the what. The what is we're going to solve quadratic equations. I think I just said that. The how is we're going to use the quadratic formula. Applications are too numerous to count. We have engineering, physics, test passing in your case, for instance. The theorem is that if you have a standard form quadratic set equal to 0, as in this case, ax squared plus bx plus c equals 0, where a is not equal to 0, then the solutions or roots are x equals opposite b plus or minus square root of b squared minus 4ac all over 2a. I believe you are all singing along as I say that. The why is we need a way to solve quadratics when we can't factor or completing the square gets really stupid. Also, it's, math, and also it builds character. I mean, big brains. Okay, there we go. So let's start by deriving the quadratic equation. Let's start with the standard form quadratic set equal to 0. And remember that a can't equal 0, because if a equals 0, then you have a 0 coefficient on your x squared term, which means you have no x squared term, which means you have no quadratic. A cannot be 0. Not that that ever comes up, frankly, but now you know. Okay, so we do want to use what we know so far about solving quadratic equations to try to simplify this a little bit. We want some other coefficient on our x squared term other than a. We want 1, right? We always want a coefficient of 1 on our x squared term whenever possible. And we can certainly do that here by dividing this guy through by a. If we do that, we get x squared plus b over a times x plus c over a, still equal to 0. We can't factor that, but we can complete the square. We're going to subtract c over a. This is a constant, right? C over a. We're going to subtract that from both sides. We're going to get x squared plus b over a times x equals minus c over a. Now we can complete the square on this guy. So x squared plus ba over x plus, we're going to divide our b term by 2, right? And then square it. Well, in this case, our b term is b over a. So we end up with b over 2a squared. Does that guy look familiar? Well, if we do it to one side of the equation, we have to do it to the other. So let's go ahead and do it to the other. We're going to add b over 2a to that side of the equation as well. Okay. A little dry because I'm still drinking coffee, even though it's like 4 o'clock in the afternoon. And I will know immediately tomorrow, I'm going to say about 7:30 in the morning, who has watched this video and who hasn't, because there are several of you who want me to quit drinking coffee, and I'm going to hear about it if you've actually done your homework. All right, x plus b over 2a, right? We can factor this guy now. It's a perfect square trinomial, and we can factor it to this form. Set it equal to, I'm going to actually apply my exponent to this term and get b squared over 4a squared. And we still have our minus c over a. Everybody with me so far? Okay. If we take the square root of both sides, we get, on this side, x plus b over 2a. Over here, we get square root of b squared minus 4ac. I'm assuming you guys know how that I combined these fractions, that I subtracted ca from b squared over 4a squared, and to do that I had to get a common denominator, which means I had to multiply both sides, both numerator and denominator by 4a, right? But if not, now you know. So we get b squared minus 4ac over 4a squared. Well, we can find the square root of 4a squared, right? Square root of 4 is 2, square root of a squared is a, but there's not much we can do with the numerator. So we're going to leave that alone. And we end up with, forgot my plus or minus b squared minus 4ac all over 2a. All right, we still haven't solved for x though. We still have an x plus b2a over here. So we need to subtract b over 2a, and we get x equals opposite b over 2a plus or minus square root of b squared minus 4ac. Whoops, I'm going to rewrite that. That's just ugly. Plus or minus, oh my goodness. Still with me? And notice we have common denominator here, right? So we end up with our old friend, the quadratic formula. Now, I want to point something out. Notice we have opposite b over 2a here. Where have we seen that before? Isn't that just the x-coordinate of the vertex of our parabola? In fact, it is. So if we, for instance, had, no, go away, a parabola, oops, like so, with our axis of symmetry, we have our solutions on either side of the axis of symmetry, and they are equidistant from the axis of symmetry, by definition, right? This is the same distance as that. What is that distance? If this is minus b over 2a, and f of minus b over 2a, right here at the vertex, what is this distance? Wouldn't it just maybe be that? I think we should explore that possibility. Not right now, but soon. Well, it turns out that the quadratic formula, once you've taken out this opposite b over 2a, what we're left with gives us another hint at the quadratic function that we're dealing with. Specifically, this mess inside the square root is called a discriminant, and that tells us the number of real solutions that we have. So a discriminant is the b squared minus 4ac mess. If b squared minus 4ac is greater than 0, then we have two real solutions. If b squared minus 4ac is equal to 0, we have one real solution. And if our discriminant b squared minus 4ac is less than 0 or negative, we have no real solutions. This makes sense if you think about it. Because the discriminant is inside a square root, if you have b squared minus 4ac and it's positive, let's say this evaluates to a positive 4, you can take that square root, right? It's going to be plus or minus 2. There are your two real solutions, right? If b squared b squared minus 4ac evaluates to 0, what's the square root of 0? 0. That's one real solution at 0. The only solution is where the graph crosses the x-axis, and in this case it crosses in exactly one place, and that's at 0, or intersects in exactly one place. It doesn't necessarily cross. Okay, and then b squared minus 4ac less than 0 means that we end up with something inside the square root. Let's say it's negative 4. Well, what's the square root of negative 4? Well, it turns out it's a complex number, which in complex numbers involve imaginary numbers, and we're going to get to that in the next session, but no real solution. So that's 0 real solutions. And that's all there is to that. We're not going to do any examples where we actually solve a quadratic equation using the quadratic formula. We'll do that in class. I know you already know how to apply this formula. We will delve a little bit deeper, though, into the discriminant. And the discriminant is stuff that's something you're going to need to understand. You will see discriminant questions on quiz. Well, we won't have a quiz on it, but on the next test. So you need to understand how to use the concept of the discriminant.